Hello everyone, I am Omar Tata, a PhD student at the Faculty of Science and Technology in Bani Mellal, and I will present the method of reanalysis after the reconstruction of the flexibility matrix for the modified dissipative system.
I will present my presentation according to this plan. Introduction, structure modification problems through transfer functions, general formulation, case of degree of freedom connected to Earth, FRF matrix evaluation, estimation from an update finite elements model, estimation using experimental measurements, reconstitution using the identified one solutions, direct evaluation of FRF matrix, evaluation by spectral factorization of the square submatrix, example and conclusion.
This work, we first developed a technique of structural modifications based on the knowledge of the frequency response functions with respect to the original structure and introduce modifications. Then, after having exposed the conventional estimation techniques of the dynamic flexibility matrix, we proposed a technique which allows us to evaluate the complete matrix without using a model identification. The idea is extended and combined with a proposal which makes it possible to choose for numerical simulation and optimal placement of the excitations. General formulation, the modified structure can be represented by an assembly of two subsystems, the initial structure and an additional system consisting of the introduced modification. The equation, the particular solution of the structure in its initial states, under a harmonic excitation is expressed represented in matrix form as equation 1. To reduce the writing, we eliminate the S arguments. The above equation is partitioned into the formed equation 2. The relation of FRF of the initial system subjects to the forces of connections. Due to the introduced modifications on the degree of freedom of type A is written in equation 3 and equation 4. The additional system consisting of a few known parametric modifications which do not modify the order of the system is represented by the dynamic stiffness matrix in equation 5 and equation 6. After using equation 3 and 6, equation 4 can be formulated as equation 7. For the problems concerning the attached the degree of freedom to the ground, in the simplest case, we choose for the disturbance matrix delta MAA equal O and delta KAA is a diagonal matrix with very large diagonal elements. Then the perturbation of the rigidity connects in a quasi-rigid way the degree of freedoms to the fixed reference. Equation 7 reduces to the equation 9. If we take delta KAA in the following form, delta KAA equal K multiply matrix identity. K is a positive scalar and matrix identity is a matrix of A order. In this case, where the data come from the measurements, one is often forced to operate with a reduced submatrix HCC, where C represents the limited number of sensors placed on the test structure. The elements of HCC are generally evaluated either by reconstruction from the eigen solution identified or by direct measurements of its the following form: independence elements. A second way to determine the FRFs of a dampened structure consists in using an FRF synthesis based on a finite number of eigenvectors and eigenfrequencies of the structure. If we consider a structure with an equation 10 in a given frequency band, we can, with sufficient precision, express an equation 8 approximately by an equation 11. In practical cases, only the submatrix HCC calculated or measured is used. Frequently exploited. The equation for is then write as in equation 12. The problem is that for the matrix of static residue HCC and SS, we can identify only p columns. We missing information can induce for some effects on the unknown columns of HCC, especially in the region where the residual terms have a preponderant role. To get around this problem and that of the extraction of the clean solution, we are interested in the direct reconstitution of the dynamic flexibility HCC from knowledge of a submatrix H1 of HCC. Consider an example of a mass spring and damper system with the following parameters. The results obtained between the direct calculation and the methods of equation 7. Results obtained between a frequency response function calculated with the after reconstitution method and the one calculated with the initial structure reconstitution method. Through numerical simulations, we have seen that the quality of the estimation of the FRF-HCC matrix depends on several factors. In the case where a degradation in the quality of the estimate is observed, even with a better choice of the position of the exiles in an increase in the number of exiles in correct, this defects the increase in damping also makes it possible to improve the quality of the estimate and attenuate the parasitic peaks which appear in the spectrum.